Let's begin our discussion of rational equations by first talking about equations that have fractions in them. Let's suppose we had the equation 1/3 x plus 5/6 equals 4. Once we have this equal sign, we get more tools to use to help us solve for x. With simplifying things, we are only allowed to multiply by special forms of 1 or add or subtract special forms of 0 in order to simplify. Here with an equation, though, we get the added benefit of being able to multiply both sides of the equation by any non-zero number and eventually adding and subtracting both sides of an equation by the same number so that we can try to get that x by itself. That's our ultimate goal with solving equations, get the variable by itself to be able to solve for it. So here in an equation, we can multiply both sides of an equation by any non-zero number. If we do that, what number do we pick? Noticing that we have fractions here, let's try to pick a number that when we multiply by the fraction, that number will cancel with the denominator so that we no longer have a fraction. And if we think about it, we're going to choose the least common denominator. If we pick the least common denominator using all of the fractions in our problem, when we multiply by the LCD, we can effectively eliminate all of the denominators. We eliminate all the fractions, but we get an equation that has the same solution set as our original one because everything that we're doing to it is mathematically sound. Let's choose the LCD for this equation. And we look that we have 3, which is a prime number, and we have 6, which is 2 times 3. And so the least common denominator for 3 and 6 should be 6. Now we multiply both sides of the equation by that LCD. So I multiply 6 times 1/3 x plus 5/6, and we multiply 6 times 4. So multiplying both sides by that LCD. And now we use other properties in mathematics that we've learned, like the distributive property. We're going to distribute the 6 inside that parentheses. 6 times 1/3 x, 6 times 5/6. And we can multiply the right side. 6 times 4 is 24. To make it a little easier to multiply, let's put those 6's over 1. 6 is a whole number, putting it over 1 only changes it into a fraction form, makes it a little bit nicer to see. It's not necessarily required, but it's a good practice to have. And now we can cancel common factors across that division bar. So 3 divides 6 2 times, and 3 divides 3 1 time. And then we've got 6 and 6. 6 divides 6 1 time. And we're able to simplify this equation with fractions in it into an equation with no fractions. And now let's use our tools for solving equations so that we can get x by itself. In solving equations, we are undoing the operations that are being done to the variable. So that order of operations that you've learned before, you may have learned about PEMDAS, please excuse my dear Aunt Sally, or BODMAS. And so just a refresher in case these are not familiar to you and you don't want to go Google them, the first letter is referring to parentheses or brackets or any kind of grouping symbol. And in rational expressions, a grouping symbol can be a large division bar. So B for bracket, P for parentheses, both of them are representing grouping symbols. The O and the E stand for order or exponent. The thought with the order is that you're also doing roots or radicals, and so those come into the exponent realm. Later in our textbook, we will learn how radicals are very closely related to exponents. That radicals can be, later on in this course, we will see how radicals can be rewritten into exponents. So it makes sense that they also fit here. In the next grouping, you see the DM and the MA. You see the DM and the MD. And the reason I'm pointing both of these out here, division, multiplication, multiplication, division, we're doing multiplication and division from left to right. If the division comes first, we do the division. If the multiplication comes first, we do the multiplication, but we're doing it from left to right. And then the last one are the addition and subtraction. And just like multiplication and division, we're doing addition and subtraction from left to right. This is when we are simplifying. When we simplify, we use PEMDAS or BODMAS or please excuse my dear Aunt Sally. When we're solving equations though, we start on the far extreme with addition and subtraction, and we work our way to the right, keeping in mind that parentheses kind of throw everything off anyways. But when we're ready to solve for a linear equation, we need to first get rid of the addition and subtraction going on with the variable term. And then we can get rid of the multiplication being done by the variable term. And then if there's an exponent on the variable term, we deal with that next. So we're going pretty much backwards. And it really depends on the type of equations that we're trying to solve, how we apply the different rules that we know. So here in this equation, we're trying to solve 1/3 x plus 5/6 equals 4. We multiply by the least common denominator to get rid of the denominators. The fractions are gone. And now we have a nice linear equation that we need to solve for. So let's start out and subtract 5 from both sides. We can multiply both sides of an equation by a non-zero number. We can add and subtract both sides of an equation by any number. And we subtract 5 because the 5 is being added to the x. Subtracting 5 gets rid of it. And so we're left with 2x equals 19. And now we want to undo the multiplication being done to the x, so we can divide. And we end up with x equals 19/2 or 9.5. Decimal numbers are acceptable. We've got a nice terminating decimal number. We aren't done though. We shouldn't just leave it like this. We need to check. Let's check our answer into the original equation. So our original equation, 1/3 x plus 5/6 equals 4. And we got x equals 19/2. I'm going to use the fraction form instead of the decimal form since I have fractions in the original equation. And we plug in that 19/2 wherever we see the variable x. We're evaluating the function now. We're evaluating the equation now for a value of x. So we need to put that value in for x. I put a question mark over the equal sign because I don't know if it's true right now. I need to verify it. I've got that little question mark up there. And now we simplify. We're going to simplify the left side to see if we can get it down to be 4. So 1/3 times 19/2 plus 5/6 equals 4. We've got fraction multiplication. We multiply straight across. 1 times 19, 3 times 2. Notice we have common denominators, so we don't need to worry about trying to get common denominators. We can just add our numerators together. 19 plus 5 is 24, and 24 divided by 6 is indeed 4. So I know that x equals 19/2 or 9.5 is our correct solution. How do we take these skills and translate them to rational equations?